Hi, I'm Jenny Gendron of Altera. As you've probably experienced, designing video processing systems can be a time-consuming process. Not only do you need to implement several complex functions to make it happen, but you also need to connect these functions for your video processing design to work. In this video, we'll walk you through a demo that shows how quickly and easily you can build a complex video chain using pre-verified configurable building blocks. These building blocks carry out specific functions, so you don't have to create these functions from scratch. Our demo requires just a few components: Altera's video and image processing suite of intellectual property cores, our Nios 2 embedded evaluation kit, which features a Cyclone 3 FPGA, a video source, and a composite cable. For today's demo, we will use an iPhone containing a video file. Our Video and Image Processing Suite, or VIP Suite as we call it, contains an array of mega-core functions for your custom video and image processing designs: a color space converter, an alpha blending mixer, a polyphase scaler, and a motion adaptive deinterlacer are just a few of the functions you get with the suite. All of the cores use an open, low-overhead Avalon streaming interface standard, which helps to connect the functions. And together, these cores and the streaming interface standard can move you quickly from the start of your project to a complete video system. Let's go over our demo components. We've already loaded our Video and Image Processing Suite design example onto our Nios 2 Embedded Evaluation Kit, also called the NEEC. The NEEC comes with our low-cost, low-power Cyclone 3 FPGA, and the design example uses the VIP suite of IP cores. Our design example takes an NTSC video source, which is in the 480i format, and deinterlaces it to the 480p progressive format. Then it scales the video and mixes it with a background layer. The design example also overlays a text box on the composite image. All of the three layers are under runtime control by the Nios 2 embedded processor. This means that Nios can change the size of our video, affect characteristics like the colors in the test pattern, or move the video on the NEEC screen. Now let's turn on the NEEC. Select our design example and push the load button on the screen to get started. While the design example is loading, we'll go ahead and connect the NEEC to this iPhone using our composite cable. The iPhone will stream a 480i NTSC video signal that will be deinterlaced, scaled, and mixed with the on-chip generated background image. Let's open the video file from the iPhone. And we can view it here on the NEEC. By touching the NEEC screen, I can take control of the output image. To showcase the runtime capability of our design, we'll use the NEEC's touchscreen, which serves as a proxy for the Nios 2 processor. Nios basically updates the programming of the design in real time based on the commands we execute from our fingertips on this touchscreen. For example, let's take a look at resizing. On the touchscreen here, we can easily change the size of our video. When we drag the corners up, the Nios 2 processor senses that we want to change the output size of our video, so it reconfigures the scaling engine frame by frame. Changing the behavior of the video mixing engine is just as easy. When we move the video block around on the touchscreen, the Nios 2 processor reconfigures the video mixing engine using the alpha blending IP core. In this way, we can easily change the position of the foreground image. We can also overlay any graphics or text that's rendered and stored in on-chip memory onto our video image, or anywhere on our screen. Let's move the position of this overlaid text onto the video block. This is useful in applications where you want viewers to see a company name or a logo. These are just a few of the video processing functions that our IP suite can handle. Through this demo, you've seen how complex video processing functions can be performed on a low-cost, low-power FPGA. Since the IP cores do the work, you're left with a much simpler design methodology. Give these IP cores a test drive yourself and see how you can simplify your video processing design.